Okay, if you'll take 2 minutes, turn in your homework, please. We are where we need to be. I'm slightly behind where I was last year. I'm just letting you know. But by Friday, please do not be absent tomorrow or Friday. But on Friday, orders, your attendance is off and on. Don't be absent next 2 days, especially. So by Friday, we will be where we need to be. All right. I will make sure I cover everything. Please do not forget you're gone next week. Okay. So I haven't made up my mind how many assignments I'm giving. I don't know if it's. I think last year I gave 3. But you're gone 9 days, correct? You're gone 9 days. This is the most important chapter, so I'm going to give you 3 assignments. So in my mind, I'm just saying expect 3 assignments. But they'll be regular homework assignments. They won't be longer than the usual. There'll just be 3 regular homework assignments. If you're smart, guys, here's what I recommend. The weekend homework will be sent on Friday, Saturday, Sunday, or Friday. So if you're smart, get the weekend homework done immediately. Do not wait. Okay, this will be foolish. The previous Sunday morning, you're like, oh my God, what is assignment 1? It's all going to be sequence and series. Like, man, I've forgotten everything. To be very irresponsible. Okay. We are about 85% done with where we need to be. So tomorrow we'll be at 95%, and then by Friday we'll be at 100%. Okay, we're getting close. All right. We're starting with a brand new test. So today we are learning 2 tests. Okay, I was planning on doing 3. I planned for 3, but the time limit did not allow me. So we'll do 2 tests. So stop. Don't write. So I have to give you some notes. We're learning something called the ratio test. So write down some notes, please. So this is what is called the ratio test. The ratio test says, so take the limit, the infinite limit, of the ratio of the n plus 1th term, as in the next term, and the preceding term, like regular nth term, okay? Okay, let's talk about it. Let's make a guess. So this is like the infinite plus 1 term, and this is the infinite term. Do you want, if you're saying the sum exists, that ratio should get smaller and smaller or larger and larger? Nobody speaks. Just use common sense. This is like the 5 billion 1th term. This is the 5 billion term. And the goal is, well, I should be able to find the sum. All right. So should that ratio, so the next term over the preceding term, should that number be a small number or be a large number for the entire sum to exist? Louder? So it's like the 5th term over the 4th term. Do you expect to be a large number or a small number? Small? If, assume we're saying that ratio, the billion term over the previous term is, say, 2. Doesn't that mean the billion and 1 term is twice the preceding term? Am I making sense? Are those numbers getting larger and larger then? Do you understand the logic? So, I expect that ratio to be below. Thank you. Oda is one of the smartest guys I know. He correctly says, I expect it to be smaller than 1. So please write down, that's the lesson. If that ratio is smaller than 1, then summation an converges. Okay, that's how easy it is. On the other hand, if that ratio is bigger than 1, summation an diverges. And then finally, if it is equal to 1, inconclusive. I am so pregnant. I'm kidding, I meant screwed. I just use the synonym for pregnant, for screwed, pregnant. Okay. But I hope some of you enjoyed that. Okay, it's inclusive. I said I am so pregnant.
Thank you.
I meant like screwed. So. I mean, one is a consequence of the other, just to be clear. 2, like, I just thought laterally. It's a lateral.
Just 2 for 2 today. So you're 2 for 2 today.
2 for 2 today. What was the first one?
No, it was a little two-part joke.
Oh, two-part joke. Okay. All right. So that's the ratio test, and we'll apply. It's very, very simple. It's very, very simple. The kids in the other class are, oh my god, it was an easy lesson. All right. Let's take on example number 1, please. Or A. I don't care what you call it. Romero, wake up. Focus. Okay, stay with me. So I'm going to start. Okay, you're copying the problem. I'm going to start the problem. So I'll first apply the ratio test, which says take the limit n approaching infinity, a n plus 1 over a n, which is limit n approaching infinity, absolute value. Okay, now stop. So let me just show you the algebra. Please understand, this is the nth term. Is that clear? This is the nth term. So how do I get the n plus 1th term if I know the nth term? What do I do with that guy? Replace. No, that is the nth term. I need the n plus 1th term. We talked about it on Friday when we began the lesson. Replace. You mean the other way around? You said replace n plus 1 for n. Replace n. No. You say replace n for n plus 1.
Oh, so just.
You mean replace n by n plus 1. I'm just correcting a preposition. Okay? I'm an English purist. If you say, so we should replace.
Change that for n plus 1.
Exactly. So replace n with n plus 1, correct? Yes? That's what I'm going to do. Alright. So I'm going to skip a step. Everybody, I'm going to skip a step, see if you can play along. So will that become n plus 1 minus 1? Which is n. Is that clear? And now watch this. I'm going to do more crazy algebra in my head. And I hope you can play along. You can show the work. Don't get me wrong. You can totally show the work. But I'm going to do it in my head. Watch. Should I replace n with n plus 1? Will that n plus 1, Ms. Mendoza, be in parentheses actually? So it will become 2n plus 2. Take away 1. 2n plus 1. So 2n plus 1 factorial divided by. Why divided by? Because this says take the n plus 1 term and divide by the n term. Wait a second. Isn't that the nth term? Let's plug it in. Divided by 2 to the power n minus 1 over 2n minus 1 factorial. How do we always divide fractions? Okay, so good news, guys. This step that I showed here, look at me. This step that I showed here, I will never show again. Nor should you on your homework. Ms. Masuk will not. Why? Because the multiplication by reciprocal we'll do directly. Relax, play along. Limit, don't forget to write the word limit, please. Chapter 1 rules. You're taking limits. 2 to the power n over 2 to the power n plus 1 factorial times 2n minus 1 factorial over 2n. Okay. Now stop. Your homework challenge will be this. Can I do this directly? Let me show you how easy it is. Look at the board. So replace the n. I'm speaking, so look at the board. So I'm replacing n with n plus 1. I got that. Alright? Can I just flip that guy there? Did everybody understand? Like I can do that in one step. I don't need to. Because divided by, I'm going to multiply that reciprocal. Flip the top and the bottom. You can do that. So we can save a step. Okay, now girls, especially writing good notes and you have colorful pens, please take them out. This is the time. This is the purpose. Like your entire life has been for this moment. You have colorful pens and pencils and highlighters. Alright? It's like, okay, now I feel fulfilled. Okay? This is the reason for my existence. Okay, so watch. I'm going to pair up terms. Can you see? That guy pairs up with that guy. It's usually diagonals pair up. And then this guy pairs up with that guy. So I want to rewrite it so it looks easier to work with. So this is 2 to the power n over 2 to the power n minus 1. And then that guy is 2n minus 1 factorial over 2n plus 1 factorial. Okay. I just need to simplify. I'm almost done without you being aware. I'm almost done with that problem. Okay. By yourselves. Use a little common sense. Put your pencils down. Use your imagination. That's 2 to the power of some power divided by 2 to the power of the preceding power. If I take that ratio, what will I just get? Say that loudly. You're correct. Say that loudly. 2 to the power of 1. Because, for those of you who say, I don't see that happening. Look at me. Isn't that like 2 to the power of 5 over 2 to the power of 4? One proceeding. Should just be 2 then. Are you able to follow that? If you're unable to follow that, let's do algebra. I'll show it only once and I'll never show it again. Play along. If I'm dividing, should I subtract the powers? I'm going to mathematically prove why Miss Dong is right. Minus n plus 1, I'm subtracting the denominator. I switch the sign. Will the n's cancel? And I get 2 to the power 1. Again, the division rule for exponents, you subtract the powers. So n minus n, and then switch the sign, plus 1. The n's cancel, you get 2 to the power 1. In simple language, it's like 2 to the power 4 over 2 to the power 3. Yeah, that's just 2. Okay. So this guy is 2. So I'm going to start writing it down. Okay. Oh, Friday's lesson. That's why Friday's lesson was useful. Is that 2n minus 1 factorial and 2n plus 1 factorial? From Friday's lesson, which is the bigger guy? So should we start from there till we reach the smaller guy? Let's do that here so we can save a step. So that'll be 2n plus 1. What will the next term be? 2n and then 2n minus 1 factorial. Will this guy and that guy cancel? Factorial. So which are the 2 leftovers? 2n plus 1 and 2n. Okay. Guys, we're done. We're done. We're taking the infinite limit. What's the leading term on the bottom? 4n square. Take the limit. What do you get? When you take the hint, that's 2 over 4n square. So what's your limit going to be? 0. Look at your notes. So converge or diverge? Look at your notes. You're correct. Why? What do your notes say? Because you're less than 1. Therefore, summation and we have to write a conclusion. Converges by ratio test. And that's how easy the ratio test is. It's just a little bit of algebra you're learning new. Again, if that ratio, the infinite limit of the ratio is less than 1, converges, otherwise diverges. While I erase the board, take 30 seconds, observe how we did the reciprocal, how we did the leading term, how we computed the factorial, blah, blah, blah. Okay, I'm being a bad teacher because I'm answering the question that is troubling some of your minds, the more inquisitive amongst you. Look at me. Your question is, Rama, how do I know I should use the ratio test? Yes? Use it, because I'm going to keep in mind today's homework, I'll just give you a mix. How do you know a problem uses the ratio test? So I'm giving notes. So write down when to use. Draw a skull. When do you know to use a ratio test? When to use a ratio test? So when the expression involves, again, 99 times out of 100, this will address your issue. So the expression involves products, ratios. Guys, ratio just means monkey over donkey. Okay, division. And powers. And finally, factorials. If more than one of these is satisfied, use the ratio test. And let's look at problem A to see, yes, it is being satisfied. Do we have powers? Do we have quotients and factorials? Ratio test. Now, you may say, wait a second, that's every problem. No, not every problem. Have a look at yesterday's homework. No products. No only powers. Can you see I have only powers like that by itself? That's not ratio test. You will not use ratio test for that one. Is that clear? So the ratio test is very unique. So have a look at this problem. Copy down B. Do you see powers, products, and quotients? And nothing else. You don't have dangling plus signs. You don't have dangling minus signs. So you can use the ratio test. Don't forget to start with the formula. If I showed you the actual AP grading rubric, they will show that formula. So take the ratio of the n plus 1th term over the nth term. Oh, by the way, I don't know if you're aware of this. Guess what Rios is doing today? Homework. Rios is doing our homework.
I'm serious. thought you were gonna say something like she has a race or something. Or...
She might. She's still doing her homework afterwards. She's going to race to do her homework. That works too. Yes.
Just to make sure that's absolute value.
Yes, that's absolute value. Yes. Did you take this down? Now, related to what Mr. Javidi said, is that absolute value? Do I need to write that down? Does everybody get it? I mean, I'll take absolute value on -1 or +1. Okay, for only this question I will write it, and I want to show you something. For only this one I'll write it. Equals limit n approaching infinity. Guys, limit word appears in every step. Marzook, every step. Just being sure. Okay, -1 to the power of n plus 1. Very good. N plus 1 minus 1 square over n plus 3 dot parentheses 2n plus 5. For those of you who get it, 2n plus 2 plus 3, 2n plus 5. Oh, using my reciprocal trick, what am I writing on the top left this time? N plus 2, 2n plus 3, bottom left, -1 to the power of n minus 1 squared. I hope you understood the shortcut, like we don't need to actually write all that. We can multiply by the reciprocal directly. Is that clear? Okay, now watch. Okay, girls writing good notes. This is the moment you've been waiting for. Take down your highlighters. I'm going to pair this guy with this guy. This guy will pairs up with that guy. So the algebra becomes very easy. This guy with that guy. And then finally, that guy with that guy. So I'm going to arrange them neatly. Now, they may be the cocky amongst you saying, nah, I'm not going to do it. But please, you'd better get it right every single time. No exceptions. If you say, no, I'm going to fumble sometimes, then it's smart to do this. Because the limit is extremely easy to take once you pair them up. So -1 to the power of n plus 1 over -1 to the power of n. I'm just pairing them, I'm writing one beneath the other. You will be faster, trust me, you will be faster. N square over n minus 1 square. N plus 2 over n plus 3. And then finally 2n plus 3 over 2n plus 5. Okay? Let's simplify, take the limit. Like in the previous problem, again, we're almost done. I'm literally 30 seconds away from being done. Because this makes it so much easier. What's negative, like the previous problem, what's any number divided by its predecessor in terms of powers? Will that be -1 then? But what's here? Absolute value. So can I cross out? Now, that's why I said we don't even need to start writing it. Is that clear? Okay. Oh, what's the leading term here? N square. The leading term is n square. Oh. What's the leading term on top? N. Leading term on the bottom. N. Leading term top right. Leading term bottom right. So, what's your absolute value really? Look at all the terms. 1. So, what's our conclusion? Inconclusive. I was giving you an example of an inconclusive ratio test. Stop. Bad news. Bad news. Put your pencils down, right? Inconclusive. Ratio test inconclusive. Bad news. If the ratio test does not work, what are we supposed to do? Sorry? Go on. Go on. Use another test. What test should we start with? Nth term. Do the nth term test. Go on. Do the nth term test. Ignore the -1. The -1 plays no role. What is the nth term test say? What value do you get? Consider leading terms at top, leading terms at bottom. What do you get? Javidi? So, guys, he correctly says the nth term test is 1. Therefore, no. Wait, you're not paying attention. The nth term limit was 1. Therefore, how does the test go? Therefore, diverges? Why? Shut up, let him finish. Let him figure it out. What does the nth term test say? We learned it yesterday, the day before. If the nth term is 1, hint, Javidi, it's not 0. Therefore,
wait. I'm sorry, I'm having a...
Okay, Mr. Torres. The nth term we got to be 1. Therefore, Ms. Babar.
The term diverges
Sorry, say that again.
it diverges and term diverges at greater than or equal to 1.
That's what the end term test says. What does the end term test say? This is not this is not P series or Geo series test. This is the nth term test. What does the nth term test say? Okay, Ms. Romero. If it is not 0, we got 1. And it is not 0. Therefore, it diverges. Okay, so please write this down. Again, the limit. Oh, no, sorry. Just say diverges by end term test. Now, I hope, because I did not do the work, I said take the limit. So remember, limit n approaching infinity, here's my work, is 1, which is not 0, Mr. Javidi. The end term test says if the end term is not 0, because Mr. Javidi, here's the explanation. Guys, look at me. Here's the intuitive explanation that I mentioned yesterday. Isn't that the number 1 added to itself infinite times now? Is that going to be infinity? Okay, so please understand the end term test in simple language just says if the end term limit of the end term is not 0, then you must be diverging. That sum does not exist. Is that clear? 1 is not relevant for the end term test. Everybody okay there? Okay, now stop. Banchan was saying something. Go on, Banchan. What were you saying?
So we have to do another thing like modify G.
No, it diverges, silly. We're done.
Okay.
Remember, we proved it diverges.
What was the thing where like you got let into the club?
No, sorry.
What was the thing where you got let into the club?
Oh, no. He says you got into the club. That's if the end term was 0, you enter the club. Here it is not 0, so the bouncer threw you out. Like you're not part of the club now. Okay, it's non-zero. Yeah, sorry, go on. Shh, sorry.
If it was convergent.
No, stop. Shh. Okay. When he says if it was convergent, when you say if it, do you mean the ratio test or do you mean the end term test? Stop. Okay, me and Marzul had a good discussion. Everybody, look at the board. Shh. Look at the board, please. Alright. If you can answer this question correctly, it means you have mastered the end term, you have mastered the lesson pretty much. Nobody speaks, look at the board. Okay, for Mr. Arnold, who is watching the video. Here's the question. Nobody speaks, put your pencils down. You can write it or not. I don't care. But this is a concept question. Okay? I was afraid Mazu will get it wrong, but she got it right. She answered this correctly. So what's this, please? Sorry. Okay, let me give you a warning. It is a trick concept question. If you get this right, it means you've mastered the lesson pretty much. It means you've understood it. So my question is this. Look at that. I'm giving you a hint. Apply the end term test. And my question is, does that guy converge or diverge? So my question is, observe, n square over n factorial. My question to the class is, so does that series converge or diverge? Mr. Ariano. Inconclusive. He understood it. He understood the lesson. Mr. Ariano, tell the class why. Because here's what the class is thinking. Those with weaker skills. Is it n factorial rising faster than that? Is that 0? And the class is thinking converge. Tell the class why. No.
If it's not divergent, then it's inconclusive.
It's inconclusive. Please understand, we just found the n term approach is 0. And he understands it's the bouncer concept. You're just let into the bar. You can dance, but I don't know if you're hanging out with the cool kids. Is everybody okay there? Just because the n term is 0 does not make it converge. So the terminology you were using was incorrect. Yeah, because you said, what if that converges? And the thing is, no, it's called, look at the title. It's the n term test of divergence. It doesn't have the word convergence in the title of the test. It's n term test of divergence, not a convergence test. All I can say is, if it is 0, try one of the other tests. If it is non-zero, Mr. Javidi, it's divergent immediately. And we're good to go. You don't have to do anything else. Okay, Ariana, I'm impressed with you. Okay, keep in mind, the end term test does not give you convergence. I was tricking you by saying, does it converge or diverge? He said, no, you can't tell it. You can't say that. Is everybody okay there? By the way, I'm curious, because I want to give credit where, how many of you correctly had that in mind? Okay, a good number of you. So keep in mind, that was a trick question. It is not a sequence, it's a series. The series end term can only do divergence, not convergence. Okay, let's move on to the next. Oh, stop. Now, in the other class, there was a smart kid. I don't know who said. He said, Wait a second. We tried the ratio test. We got inconclusive, right? Now I'm blowing your minds. Did we not waste time? Thank you. Should we not have started with the end term test? Does everybody get it? No. I was demonstrating to you the consequence of not doing the end term test in your first step. You just wasted time. You should write the end term test in your first thing. We got 1, not 0, diverge. End of story. Why are you wasting your time on the ratio test? But two things. My goal was twofold. My goal was to first show you the concept of inconclusive, but also to kind of like gently kind of pat you saying, hey, you should be doing the end term. Why are you wasting your time? So to kind of reorient yourself. Even though it says you use ratio test, no, always do the end term first. Why are you wasting it? Yes, go on.
So even though the homework's going to be a mix, you want us to start with end term?
Always, no matter what the problem is. Because Mr. San Diego, if it diverges, why are you wasting time with a geo test or a PCDs or LCD ratio? Why? It diverges. Okay, last example of this kind, copied on C. No, we'll do 2 more examples. Okay, copied on C. Stay with me, do not fall behind. Oh, sharp kids, you can copy the problem. Can we directly go in? Plug in n plus 1, okay? So limit n approaching infinity, an plus 1 over an. Limit n approaching infinity. Do I need to write the negative 1? Very good. N plus 2. 2 to the power of n. E to the power of n plus 1. Careful. Top right, en, very good. Bottom right, n plus 1 dot 2n minus 1. Okay, now look down, rearrange the terms. Pair them up, so the terms match up. So the algebraic simplification will be much faster. Okay, and then check your answer against the board after you finish the algebra. Okay, what does this guy become?
2.
Where? On the top. Okay, now careful. What does that guy become? Where? On the bottom, very good. The n plus 1 is bigger than that. He is on the bottom. And then when I take the limit, what will that guy become? 1 is leading term n, 1. So what's your absolute final expression? Write a conclusion yourself. We're done. Write a conclusion. Hint. Good news. The ratio test works like the geoseries test. And this guy is... ¿Por qué? So?
Oh.
Okay, thank you. You're confusing the class. Okay, E is bigger than 2, as Mr. Bandhan correctly says. Therefore, that ratio is less than 1. Summation an. Don't forget to write the conclusion. Summation an. Therefore, converges by ratio test. Okay, this is the hardest problem you will encounter. It does not get more difficult than this, but I will tell you this is a challenging problem. It came in 2016. FRQ. 2016, this question appeared. And I have to tell you, I don't have confidence that too many kids figure that one out. The algebra was very weird. Okay, take that problem down, please. It's because of this guy. Can you see? We almost seldom have n to the power of n. That is a rare expression. Usually 2 to the power of n, or n squared, but not n to the power of n. The calculus became very complicated. But let me show you how. So first, limit n approaching infinity, an plus 1. Please mimic classroom behavior. Do not do your own thing. You will not know this, but when I speak to Ms. Marzouk, we discuss the homework. I actually say, did you remember to write this? She said, yes, Rama, I wrote it. Did you remember to write that? Yes, I did that. Because I want kids to say, okay, that's how you're supposed to do. I said, did you identify Bn correctly? Did you write a conclusion properly? Okay, what's my numerator? Careful. N plus 1 to the power of n plus 1 over n factorial. N minus 1 factorial over n to the power of n. Okay, rearrange terms, look down. Guys, which is the bigger guy? N factorial or n minus 1 factorial? So what should you do on the bottom? So upon simplification, what do you really get? On the bottom, thank you. So it's actually 1 over n. Yes? Yes.
What happened to the -1?
Oh, according to Mr. Javidi, are we not taking absolute values? What's the absolute value of a negative number? Just that expression. So we have stopped writing it. Okay, you can totally write it, but 2 steps down you have -1 dangling, absolute value -1 vanishes. So since the previous problem, Ms. Hanson, we stopped writing. Is everybody okay so far? Okay, now let me show you this. Now observe the algebra. I'm going to do a sidebar. Okay, do a sidebar, please. Ms. Dawn, do you believe the camera captures this too? Probably?
Yeah.
Probably. Okay, I'm doing this expression, this guy, as a sidebar. Relax, I'm not abandoning the 1 over n. I will come back to it. I just want to show you how that is simplified. So I'm going to rewrite that. I'm going to make the powers the same. Everybody, do you see that n plus 1, that's n? I'm making the powers the same, just like geoseries. So is that n plus 1 to the power of n dot n plus 1? Everybody okay there? Over n to the power of n. Okay, I just split that up so the powers are the same. So that can I, just like geoseries, can I merge the powers now? So is that basically n plus 1 over n to the power of n dot n plus 1? Yes? Okay, now what's this algebra? Can I split that up? I'm going to just split it up. So does that become 1 plus 1 over n to the power of n dot n plus 1? Does anybody remember from pre-calculus or pre-calculus honors, IM3 we did not discuss this, what the infinite limit of that guy is? So I'm going to put it back there, okay? So that guy is really limit n approaching infinity, 1 plus 1 over n all to the power of n times n plus 1, and this is a division divided by n here. Okay, so I rewrote it like that. Again, this is there, n plus 1 on top, n on the bottom. Is that clear? Does anybody remember ever seeing that limit? In the other class, a couple of kids said, yeah, I remember Miss Baylor going over this. You learn this in pre-calculus. It's a famous limit. Okay, when I did a Desmos demo, kids were like, whoa! It was one of the best demonstrations. I did not know how impressive it was till we did it. Okay, so what's this? Is n basically approaching infinity? Okay, now let me show you the let me do it the intuitive way. How your intuition means common sense, what your simple reasoning says. What's 1 over infinity? What's 1 plus 0? To the power of infinity? About 1? Not even close. Okay. So what's this? 1 plus 1 over. I'm going to choose like a billion. Okay, I'm going to choose a billion. That's close enough to infinity. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's a billion. Again, we have 1. Okay, we have 1 there. Because 1 divided by that is 0.001. 1 plus that is that. Okay, now watch magic happen. To the power of. Okay, now watch magic happen. Observe this guy. Observe your result. 1.